What's up guys, this is Masi. Welcome to another video. This video I want to talk about projectile motion. So what does that mean when we're talking about projectile motion? It means that it's a special case of two-dimensional motion, which in this case a particle moves in a vertical plane with some initial velocity, which we call it v0 usually, and its acceleration is always the free fall acceleration, which is the gravitational acceleration, or g, which is downward. Such a particle is called a projectile, which means that it's projected or launched, and its motion is called projectile motion. So the projectile is launched with an initial velocity v0 and can be written as v0 equals to v0 xi plus v0 yj, so it can have in both directions. So the components v0 x and v0 y can then be found if we know the angle theta between v0 and the positive x direction, which we can find it using these two formulas. v0 x equals to v0 times cosine theta naught, and v0 y equals to v0 times sine theta naught. We had these equations before, which x equals to x naught plus average velocity times t, and average velocity is v naught plus final velocity divided by 2, and when you sub it there, you're going to have v average equals to v naught, which is the initial velocity plus 1/2 acceleration times time. So when I substitute this one into the equation, I'm going to have x minus x naught. That will be equal to v0 theta, v0 t plus 1/2 a t squared. And another formula we can get is v squared equals to v0 squared plus 2 times a times x minus x naught. We had these equations before, but here when we are talking about x and y direction, in x direction there is no acceleration at all. So when we are talking about this formula, this part is going to be cancelled out, and we will end up having x minus x naught equals to v0 x times t. And v0 x, we already found that that's equals to v0 times cosine theta naught. What about the y direction? Y direction, we can rearrange this formula in y direction again. Y minus y naught equals to v0 y times t minus 1/2 g t squared. The reason it's negative here because acceleration is negative g. So we already found that v0 y equals to v0 times sine theta naught. So when we sub it there, we end up having this expression. And also we can say that vy, which means that the final velocity equals to initial velocity in y direction, which is v0 sine theta naught minus gt. And then we can say vy squared, which is final velocity squared, equals to v0 sine theta naught to the power of 2 minus 2g y minus y naught. So these are going to be the equations you need for solving projectile motion questions. Let's see some examples. In this example, we have a dart which is thrown horizontally with an initial speed of 10 meters per second toward point P. The bullseye on the dartboard, and it hits at point Q on the rim vertically below P, which is 0.19 seconds later after we release the dart. So we need to find out two things. One of them, what is the distance PQ, and how far away from the dartboard is the dart released. So we need to adopt a positive direction. So we can say the velocity is horizontal, so v0 equals to v0 x. That's going to be equal to 10 meters per second. And there is no vertical velocity, so that's going to be 0. So how to find the distance between P and Q? We can say y minus y0 equals to v0 y times t minus 1/2 gt squared. And if we neglect y naught, we assume it is 0, and we know y naught y is 0, we can say y will be equal to negative half gt squared. And we learned that t, the time, is 0.19, and g we know is 9.8. So we have 1 over 2, 9.8 times 0.19 to the power of 2. That will be 0.1769 meters. Now we need to find out how far away from the dartboard is the dart released. It means that we need to find out x. X is v naught x times t. v naught x is the same as v naught, which is 10 meters per second. So x will be 10 meters per second times 0.19, and that will be 1.9 meters. So the distance and the answer to part B is going to be 1.9 meters. In this example, it says small ball rolls horizontally off the edge of the tabletop that is 1.2 meters high, and it strikes the floor at a point 1.52 meters horizontally from the table edge. Part A, how long is the ball in the air? And part B, what is its speed at the instant it leaves the table? So what we need to do, we can say that y minus y naught equals to v naught y times t minus 1 over 2 gt squared. Now what we can do, y naught is going to be the initial height and y is going to be the final height. We can say the final height is 0 minus 1.2 because the height is going to be 1.2. So it's going to be minus 1.2. V naught y is going to be 0 because it moves horizontally right from the beginning. So this part is going to be 0. And then you have negative 1 over 2 g, which is 9.8 t squared. And based on that, we can say t squared is going to be 1.2 times 2 divided by 9.8, which is going to be 2.4 divided by 9.8, power of half. That will be 0.22245, and t is going to be, when you find out the square root, is going to be 0.495 seconds. So that's going to be the answer to part A, which is saying how long is the ball in the air. And now part B, it says what is its speed at the instant it leaves the table. It means that find out v naught x, because v naught is supposed to be equal to v naught x in this example because it was moving horizontally. So we can say that since it moved 1.52, we can say v naught equals to x divided by t. So x is 1.52 divided by 0.495. That make it 3.07 meters per second. Let's see the next example. So now in this example, a projectile is fired horizontally from a gun that is 45 meters above flat ground, emerging from the gun with a speed of 250 meters per second. How long does the projectile remain in the air? At what horizontal distance from the firing point does it strike the ground? And what is the magnitude of the vertical component of its velocity as it strikes the ground? So the first of all, I'm going to have y minus y naught equals to v naught y times t minus 1 over 2 g t squared. The difference between these two numbers is going to be the height, which is going to be minus 45. This part is going to be 0 because v naught y is 0, equals to negative 1 over 2, 9.8 times t squared. So t will be square root of 2 times 45 divided by 9.8. That will be 3.03 seconds. Now next one, we have the horizontal distance traveled. It's given by this example. X minus x naught v naught x times t, because there is no acceleration in x direction. So v naught x is given by 250 meters per second, and the time is given. So the rest of it is going to be horizontal distance. So 250 times 3.03, that will be 757.5 meters. Next one, we have what is the magnitude of the vertical component of its velocity as it strikes the ground. We can say Vy equals to v naught y minus gt, which is the initial velocity in y direction minus gt. We know this part is 0. So final velocity in y direction is going to be negative 9.8 times t, which is going to be 3.03. 9.8, 3.03. That's going to be 29.7 meters per second, and it is going down. We need to find out the magnitude, so we put it in the absolute function, which is going to be positive 29.7 meters per second. This example, we have the current world record motorcycle jump is 77 meters. Assume that he left the takeoff ramp at 12 degrees to the horizontal and that the takeoff and landing height are the same. Neglect the air drag and determine his takeoff speed. So now if I write the equation here, we have x minus x naught v naught x times t, and on the other hand we have y minus y naught equals to v naught y times t minus 1 over 2 gt squared. We can say x minus x naught, which is going to be the horizontal range, is given, which is 77. So 77 will be equal to v naught x times t. On the other hand, we have y minus y naught. Since it says takeoff and landing height are the same, it means that y and y naught are the same. So that's going to be 0 equals to v naught y times t minus 1 over 2 g t squared. So we can say 77 equals to v naught x times, instead of t, I'm gonna sub 1 over 2 gt squared divided by v naught y. Here we have this t and squared cancel out, and we end up having t equals to v naught y divided by 1 over 2 g, or it's going to be 2 v naught y divided by g, or we can say that's going to be equal to 2 times v naught sine theta divided by g. So now in this equation, instead of t, I'm going to put 2 v naught sine theta over g, and v naught x is v naught cosine theta times 2 v naught sine theta divided by g. So that will be v naught squared times 2 times sine theta times cosine theta divided by g. That's going to be equal to horizontal distance, which is 77. Now 2 times sine theta times cosine theta is going to be equal to sine 2 theta based on the trigonometric identities divided by g. So, or you can say horizontal range is going to be v naught squared sine 2 theta divided by g. So now we can solve it based on what we wrote. We can say v naught equals to square root of 9.8 for g times 77 divided by sine 2 times 12, because the degree is 12 in here. Sine 24. So when you calculate it, that will give you 43.1 meters per second. So in this example, a stone is catapulted at time t equals to 0 with an initial velocity of magnitude 20 meters per second and at an angle of 40 degrees above the horizontal. What are the magnitude of horizontal and vertical components of its displacement from the site after 1.1 seconds, 1.8 seconds, and 5 seconds? So we can say that initially we have v naught is 20 meters per second and theta naught is 40 degrees. So we can say v naught x equals to v naught cosine theta naught, and v naught y is going to be v naught times sine theta naught. So we have 20 times cosine 40 and 20 times sine 40. Which is 15.32. That will be 12.85. So what we can do, we can find out the x and y. So x will be v naught cosine theta naught, which is v naught x times t, which will be, we already found that, which is 15.32 times time, which is 1.1. That will be 16.9 meters. What about the y? Y is v naught sine theta naught t minus 1 over 2 gt squared, which will be 12.85 times time, which is 1.1 minus 1 over 2, 9.8 times 1.1 to the power of 2. That will be 8.21 meters. We can do the same thing for part B and C. We can just sub other numbers there. So we can say x will be 15.32 times 1.8. And here we will have 12.85 times 1.8 minus 1 over 2, 9.8 times 1.8 to the power of 2. That will be 27.58. And here we have 12.85 times 1.8. That will be 7.254. And that's part B. Part C is when the time is 5. So we're going to have x equals to 15.32 times 5 But before that, we need to find out how long it takes for the stone to come to the ground. So the stone hits ground earlier than 5 seconds. How to find it? We have y equals to v naught t minus v naught yt minus 1 over 2 gt squared, which if y is 0, we can have 12.85 t minus 1 over 2 9.8 t squared. So we will have t equals to 2 times v naught times sine theta divided by g. That will be 2 times 12.85 divided by 9.8. That will be 2.62 seconds. So it means that it doesn't take 5 seconds. So then after that we can say x equals to v naught t times cosine theta naught, or we can say 15.32 times the time of landing, which is 2.62. When we sub it there, we're going to have 40.2 meters. What about the vertical component? The vertical component is definitely going to be 0 because it's going to stay and where it lands, and the vertical component at time equals to 5 is 0. This example, we have a certain airplane has a speed of 290 kilometers per hour and is diving at an angle of theta equals to 30 below the horizontal line when the pilot releases a radar decoy. The horizontal distance between the release point and the point where the decoy strikes the ground is 700 meters. 2 questions. First one, how long is the decoy in the air? And how high was the release point? So it means that we need to find time, t, and we also need to find out the height, h or y. So let's have it here. We have x minus x naught equals to v naught x times t, which means that x minus x naught equals to v naught times cosine naught theta times t. So the distance is 700 as is given, 700 meters. V naught is velocity. The velocity is given, but it is in terms of kilometers per hour. We need to change it to meters per second, so it's going to be 290 kilometers per hour times 1000 divided by 3600. That will give me 80.6 meters per second. Sub it there is going to be 80.6. Cosine theta is going to be cosine 30 times t. This cosine 30 is going to be basically cosine negative 30, but it's going to be the same, because cosine 30 and cosine negative 30 is going to give us the same answer. So t equals to 700 divided by 80.6 times cosine 30. That will be 10.02, or let's round it to 10.0 seconds. So it takes 10 seconds. Let's find out the second part, which is how high was the release point. We can say y minus y naught equals to v naught times sine theta naught times t minus 1 over 2 g t squared. So we have height, 0 minus height, equals to v naught is 80.6 times sine negative 30 times t, which is 10 seconds, minus 1 over 2, 9.8, 10 to the power of 2. That make it that will be negative h equals to negative 893 meters, or height is gonna be 893 meters. So that's gonna be the height. In this example, we have a stone is projected at a cliff of height h, lowercase h, with an initial speed of 42 meters per second, directed at an angle of 60 degrees above the horizontal. The stone strikes at A 5.5 seconds after launching. Find the height of the cliff, lowercase h, the speed of the stone just before impact at point A, which is here, and the maximum height reached above the ground. So I'm gonna say y minus y naught equals to v naught sine theta naught times t minus 1 over 2 g t squared. So when we solve it, this part is 0, so we can say height is gonna be equal to v naught, which is 42 times sine 60 times t, which is 5.5 minus 1 over 2, 9.8 times 5.5 to the power of 2, which will be 42 times sine 60 times 5.5. That makes the h as 51.8 meters. Now part B, it says the speed of the stone just before impact at A. It means that we need to find out the final velocity. We can say V will be equal to final velocity squared at x component, Vy squared. Vx the same as Vx naught, so we have V naught times cosine theta naught. That will be 42 times cosine 60, which is going to be 21, and Vy is going to be Vy naught, which is 1 sine theta naught minus gt, which will be 42 times sine 60 minus 9.8 times 5.5. We can say 42 times sine 60 minus 9.8 times 5.5. That will make it negative 17.53 meters per second. So when you sub it there, 21 squared plus negative 17.53 squared. That make it as 27.4 approximately meters per second. This is going to be the answer to the part B. Now let's find out the part C, which is finding the maximum height. We had this equation before, which is Vy squared equals to Vy naught, which is V naught sine theta naught to the power of 2 minus 2g y minus y naught, which is going to be the maximum height when Vy is 0. We know at maximum point Vy is 0. So for a fraction of second, Vy will be 0. So we can say 2gh will be equal to V naught sine theta naught to the power of 2. So we can say h will be V naught sine theta naught to the power of 2 divided by 2g. That will be 22 times sine 16 to the power of 2 divided by 2 times divided by 9.81. That's going to be 67.5 meters. In this example, it says a projectile's launch speed is 5 times its speed as maximum height. Find launch angle. So speed at maximum height, we know Vy is going to be 0 and Vx will be Vx naught, and that's going to be equals to V times cosine theta naught. So projectile's launch speed, which is V, equals to 5 times V times cosine theta naught. It means that these two cancel out. It means that 1 over 5 is going to be cosine theta naught. So theta naught is going to be inverse of cosine 1 over 5. So that's going to be cosine inverse of 0.2, which will be 78.5 degrees. So in this example, we have a soccer ball is kicked from the ground with an initial speed of 19.5 meters per second at an upward angle of 45 degrees. A player 55 meters away in the direction of the kick starts running to meet the ball at that stand. What must be the average speed of he is to meet the ball just before it hits the ground? So first of all, I need to find out how long does it take for the ball to hit the ground. So I'm going to have delta y equals to V naught sine theta naught times t minus 1 over 2 g t squared. Delta y is going to be 0, and we have V naught sine theta t, that will be minus 1 over 2 gt squared. Then after that it's going to be 1 over 2 g2 squared V naught sine theta naught t. T and square cancel out, and we have t equals to V naught sine theta naught divided by 1 over 2g. Or we can say 2 V naught sine theta naught divided by g. So we have 2 times V naught is 19.5 sine 45 divided by 9.8. 2.81 seconds. Now the distance, it says a player 55 meters away from the direction. So we can say V average will be, we can say first of all delta x equals to V naught cosine theta times t. So it means that the location is 19.5 cosine 45 times 2.81. That will give me 38.7. So that's going to be the horizontal distance the ball traveled. So we can say 38.7 minus 55 divided by the time it takes, which is 2.81. We have 38.7 minus 55 divided by 2.81. That's going to be negative 5.8 meters per second in the I direction, which means that the average velocity or average speed is going to be 5.8 meters per second. In this example, in a jump spike, a volleyball player slams the ball from overhead and toward the opposite floor. Suppose the ball is spiked from the height of 2.3 meters with an initial speed of 20 meters per second at a downward angle of 18 degrees. How much farther on the opposite floor would it have landed if the downward angle were 8 degrees instead? So we have y minus y naught v naught sine theta naught times t minus 1 over 2 g t squared. So we have 0 minus 2.3 equals to 20 times sine negative 18 times t minus 1 over 2 9.8 t squared. So we have the quadratic equation. When we solve it, it's going to give you t equals to 0.3 seconds. When you sub it in x equals to v naught cosine theta naught t, we have 20 times cosine negative 18 t, which is 0.3. That will make it 5.71. Now if we change everything to 8 degrees, so we need to do everything again. It's going to be negative 0 minus 2.3, 20 times sine negative 8 t, everything exactly the same, 9.8 t squared. Or let's say t prime. So in that case, t prime is going to be 0.46 seconds. So again, we need to find out the horizontal distance, v naught cosine theta naught or theta prime times t, which will be 20 times cosine 8 and t is going to be 0.46. That make it 9.1 meters. So it says how much farther, so we can have delta x will be 9.1 minus 5.71, which will be 3.39 meters. 9.1 minus 5.71 meters. So it's going to be 3.39 meters.